All right, guys. Remember from the first video, the derivative of an exponential function is itself times the natural log of the base. So if the base is just e, we have this really nice property. Really nice property. Goodness, sorry, something in my eye, nothing going on here. Let's do some examples with this, and then we'll be done with the section. Example 4. Differentiate. Part A is the function y equals x plus 1 over e to the x. Oh, what have we got here? We've got a quotient. Are we going to use the quotient rule? You bet we are, right? So remember quotient rule. Right, this will be our top. This will be our bottom. So y prime is equal to low d high minus high d low, square the bottom, and away we go. The low function's e to the x times the derivative of the high function minus the high function times the derivative of the low function. The derivative of e to the x is just itself, all divided by the low function squared. And now we get some kind of nice things right here when we simplify. Look at this. E to the x times 1. That's just e to the x. Minus e to the x times this other thing, plus 1. In the bottom, we could write that as e to the 2x if we wanted to. I'm going to leave it. I'm going to leave it how it is, because we get some nice simplification here, right? That numerator factors. We can factor out an e to the x from the numerator and an e to the x from the denominator, and we'll get some cancellation. Look at that. All right, so we'll have to do it on the next page, but what we're going to get is e to the x in the numerator. If we take out an e to the x, what's left? Only a 1. And then we're subtracting by what's left over, which is an x plus 1. But remember, we're subtracting the entire x plus 1, so we're going to have to be a little careful there. And the bottom, we have e to the x squared still. Now, you can't cancel unless things are factored. All right, we have one factor of e to the x up here, and we have 2 factors of e to the x in the bottom. So they'll cancel like so. Now our numerator is kind of funny. It's 1, distribute that negative, minus x, minus 1. All that's left in the bottom is e to the negative positive x. Well, we got a plus a 1. We got a minus a 1. Hey, we're actually left with something really nice. It's just negative x over e to the x. Happy face. All right, so again, this is just like before. One of the hardest things with product and quotient rules is just your simplifying. So remember your algebra. Don't cancel until you factor. Okay? You have to factor before canceling, and be very careful with these pesky negatives. All right, we're subtracting this entire term. So that negative does need to distribute. All right, and here we go. Let's do another one. Example 5, the last example. Find an equation. Ooh, we love finding equations. Of the tangent line. Oh, we love that even more. To the graph y equals x e to the x at the point 1 comma e. E is about 2.718, I believe. Or, yeah. Wondering if I'm switching my digits. But that's what we got here. So remember the equation of a tangent line, we need to find the slope of the function. The slope of the function is the slope of the tangent line. The slope of the function is the derivative. All right. So we need to find that derivative. So we need to take the product rule to take the derivative of here, right? We have 2 functions multiplied by each other. So product rule is derivative of the first times the original second plus the first function times the derivative of the second. What's the derivative of e to the x? Y. It's nothing else but itself. All right. That's our derivative. We want to find the slope. Slope is derivative. Specifically, we want to find the slope right here. Hey, behave. We want to find the slope right here when this, at this x and this y. So we'll just plug in x. You could simplify some more here, you could factor, but we just want to find the slope anyway. Our slope is just going to be, goodness gracious. The iPad's a little wacky today. Plug in when x equals 1. It'll be e to the first power plus 1 times e to the first power. Well, that's 2 e to the first powers. Okay. Which is just 2e. All right. And again, we'll have our exact answer here. That's our slope, which is great. And now we know the slope. We know a point. All right. So we have our point up here. We have our slope right here. Point slope form. Y minus y1 equals m times x minus x1. And we already have our x's and our y's and our m's. So we'll get y minus the y coordinate, which is e, is equal to the slope, which is 2e, times x minus the x coordinate, which is 1. And you don't need to change forms. This is a perfectly good form. And let's check our answer. Let's visualize this. Let's see what this looks like. So this function over here, x e to the x, looks like this. It has an asymptote at the left for the x-axis. Then it kind of dips down and then it shoots up to the moon. All right. Let's see if we have the right tangent line. The line we found was y minus e is equal to 2e times x minus 1. Oh, look at that. That looks nice. It should be tangent at the point 1 comma e. 2.718. There you go. Got that nice tangent line right here. Again, it just kind of kisses it. Just kind of skips across. There we go. And that is section 4.2. Good luck.